Hi class, and welcome to 3.3. This is where we're going to be talking about rates of change in applied context other than motion. So our learning objective is to interpret rates of change in applied context. One thing that we're going to note is these all questions come from your AP exam. The AP exam you will definitely see a question with this rate in, rate out type of problem. And if we have never practiced it, it can look a little difficult, like how in the world do I compute this? But in reality, it's not too bad. So again, we're going to be using our calculator for all of these, so make sure you have your calculator, and you'll be putting, when we work with these equations, and I'll be reminding you when you do that, but remember, we want to put those in our y1 and our y2, so we can be using those y-vars functions when we compute stuff. Okay. So let's look at example 1. This comes from the 2010 AP Calc exam. Both AB and BC had this question. So there is no snow on Janet's driveway when snow begins to fall at midnight. From midnight to 9 a.m., snow accumulates on the driveway at a rate modeled by f of t equals 7t e to the cosine of t cubic feet per hour, or t is measured in hours since midnight. Janet starts removing snow at 6 a.m., so t is equal to 6. The rate, g of t, in cubic feet per hour at which Janet removes snow from the driveway at time t hours after midnight is modeled by g of t. And so we have that piecewise function there. So find the rate of change of the volume of snow on the driveway at 8 a.m. Okay, so even though this is just a part A question, I want to go ahead, because this is going to be a good habit for the AP exam, so I want you to put this equation here in your y1 for your calculator. Okay? So now, I'm going to go ahead and answer the question. Okay? And I can't put g of t in there because we have 3 different values. So, find the rate of change of the volume of the snow on the driveway at 8 a.m. So my keyword here is find the rate of change of the volume. Okay, so the rate, well, if you think about it, it is snowing and I am shoveling. So my rate in, the snow is falling down. The rate out, I am shoveling. Okay, so that would be f of t, my rate in, minus g of t, my rate out. Okay, well, I want to find it at 8 a.m. and since we started at midnight, this would mean t is equal to 8. So r of 8 would equal f of 8 minus g of 8. Okay, and I'm going to go ahead and put this all in my calculator. So if you're at home, you should be on your home screen, and I want you to hit the alpha calc, which brings up your y1. So you'll just go y1. And then you're going to do parenthesis 8, close parentheses, because then that's going to plug it in for you. So you actually don't have to plug in. Instead of where you see it x, plug in, or in this case t, plug in an 8 in your calculator, you can go ahead and do it like this. Okay, so minus, and again, this green part here, you're not actually going to ever show this on your AP exam. I'm just doing this for you at home so you know how to put this in your calculator. Okay, so g of 8. Well, g of 8 is 108. So this right here is what should be in your calculator. Hit enter. And I get negative 59.583. And it's cubic feet per hour. And that is my answer. Okay. And remember, I didn't have to worry about changing the label because I actually didn't take the derivative of anything. We already knew the rates. Okay, so let's go to example 2. A penguin population on an island is modeled by a differential function p of time t, where p of t represents the number of penguins and t is measured in years from 0 to 40. There are 100,000 penguins on the island at time t equals 0. The birth rate for the penguins on the island is modeled by b of t. So here is your equation here. Now, one thing you're going to do with these FRQs, because we're going to do a lot of practice with these throughout the year, is anytime it's calculator active, I am putting that equation in. So go ahead and put this in your Y1. Okay, so now let's continue. So we have the birth rate. The death rate for the penguins on the island is modeled by D of T. So again, go ahead and put this now in Y2. Okay, so that's the D of T penguins per year. What is the rate of change of the penguin population on the island at T equals 0? So how is the population of the penguins changing? Well, again, if you think about it, population changes. We get a new value each day. People are born, people die, and that is our population. Okay, so again, I'm going to just write something. So you can use R of T again. That's fine. So my rate in, that's going to be birth. My rate out is the death of the penguins. And I want to know, what is it at 0? Okay. So I'm doing R of 0 equals B of 0 minus D of 0. Now, I know this one here, you probably could look at it because we're plugging in 0 with E, and E to the 0 power is always 1. So this one might be something you can do in your head, but I want you to practice on your calculator putting these in. Okay, so you should have already put B of T in Y1 and D of T in Y2, so you should be at your home screen. So now you're going to hit that alpha F4 and click Y1. So you're going to have Y1 and then parentheses 0 minus, now I do it again, so alpha F4, this time click Y2, and then you're going to do 0. Make sure it's in parentheses and you close it, and then hit enter. So when I hit enter, I get 750. And then again, I just have to make sure I label. So this would be penguins per year would be my rate. So 750 penguins per year at time T equals 0. Okay, so pretty short lesson for once, which is kind of nice. With example 3, so this was taken from the 2017 AP Calc exam. This was question 2 for both the AB and the BC. I want you to, at home, go ahead and try this on your own. Okay, so you can look for example 1 and 2 as examples, and I want you to go ahead and do that. So pause the video and then come back and check your work to see how you did. Okay, class, welcome back. So let's go over example 3. When a certain grocery store opens, it has 50 pounds of bananas on a display table. Customers remove bananas from the display table at a rate modeled by F of T. So again, first thing you should have done is taken this equation. This goes in your Y1. Okay, so where F of T is measured in pounds per hour, and I would make sure maybe underline that too so you have your label. And T is the number of hours after the store opened. After the store has been open for 3 hours, store employees add bananas to the display table at a rate modeled by G of T. Okay, well, here's another equation. Again, I'm going to go ahead and put this in. This one should go in Y2. And again, G of T is measured in pounds per hour, and T is the number of hours after the store opened. A, find F prime of 7. Using correct units, explain the meaning of F prime of 7 in the context of the problem. Okay, so I don't have to show a lot of work for this. The only thing I'm writing on this is this on my exam would be F prime of 7 equals, and that's it, and then you're going to put your answer in here. Okay, don't show anything else. Don't rewrite the equation. Don't do any of that. Just plug it in your calculator and write your answer. So remember, if you're in your calculator, you should be hitting Math 8. So you have d dx. Don't type in the equation. We already have it saved. So you're going to put in y1 and then at x equals 7. So you should have got an answer of -8.7. 11954. And then this is going to be in pounds per hour. But remember, now we actually took the derivative. So this is per hour. So pounds per hour squared would be my label. So make sure you got that correct label. Now I need to interpret it, okay? So I got 1 point for the value. That's what I wrote in blue. So here's my 1 point for the value. Now I need to go ahead and do the meaning. Okay, so again, that's where we want to practice that NUT acronym. So the rate at which customers are removing the bananas. And again, I'm just getting this wording from the problem. You don't overthink it. From the table is, okay, well, our answer is negative, so that means we know it's decreasing by, and again, now you just write the answer. Do not put a negative in there. And if you wanted to, you can round. So 8.120. We just need 3 decimal places. Pounds of bananas per hour squared. And oh, and you can put at time t = 7. Okay, there we go. That's got our 2 points. Okay, let's see how we did for B then. Okay, is the number of pounds of bananas on the display increasing or decreasing at time t = 5? Give a reason for your answer. Okay, so I want to know, is the number of pounds of banana increasing or decreasing? So I need to figure out, well, is the rate, so that's your rate in, rate out type of problem, is it going to be positive or negative? That's going to determine if it's increasing or decreasing. So let's just say we use B of t for bananas. Okay, so again, it's my rate in, rate out. Now here's where you got to be careful. A lot of times you want to, if the first equation you would use is your rate in. It's not always the case. You want to make sure you read the problem. The F of t is my rate out. The customers are removing it. The people are stocking it is G of t. So B of t is equal to G of t minus F of t. Okay, well again, we want it at 5. So B of 5 is equal to G of 5 minus F of 5. Again, all I'm going to do is put this in my calculator. And again, you already have these equations in your calculator. So it's just your y2 of 5 minus y1 of 5, assuming you put f of t in y1 and g of t in y2. When I get my answer, I get negative 2.263. Okay, and now I need to answer. So the number of pounds of bananas on the table, it's negative, so we know it's decreasing. At time t = 5 hours. Okay, so there is our work, there is our answer. Hopefully you did well in that. If you have any questions, email me and I'll be able to help you. Make sure you do the 3.3 worksheet and your answer.